Today we're diving into a paper that tackles the challenge of scaling transformer-based large language models, LLMs, to handle infinitely long inputs. The paper, Leave No Context Behind, Efficient Infinite Context Transformers with Infini-attention, proposes a novel attention mechanism called Infini-attention to achieve this. What are the limitations of traditional transformers when it comes to processing long sequences?
Traditional transformers have a fixed context window, meaning they can only process a limited amount of information at a time. This limitation stems from the quadratic complexity of the attention mechanism, which requires storing and computing relationships between all tokens in the input sequence. As the sequence length increases, the memory footprint and computational cost grow rapidly, making it impractical to handle extremely long texts.
So how does Infini-attention address this limitation?
Infini-attention introduces a compressive memory component into the standard attention mechanism. This memory acts as a long-term storage for contextual information, allowing the model to retain and access information from previous segments of the input sequence. Instead of discarding the key and value states from the attention computation, Infini-attention reuses them to update the compressive memory.
Can you elaborate on how this memory update and retrieval process works?
The memory update is performed incrementally, adding new key value bindings to the memory as the model processes each segment of the input. The retrieval process uses the attention queries to access relevant information from the memory, allowing the model to incorporate long-range dependencies into its computations.
How does Infini-attention combine this long-term memory with the local attention mechanism?
Infini-attention uses a learnable gating mechanism to combine the information retrieved from the compressive memory with the local attention context. This allows the model to dynamically adjust the balance between long-range and short-range dependencies based on the specific input sequence.
This sounds like a clever way to handle both local and global context. What are the key benefits of using Infini-attention?
Infini-attention offers several advantages. First, it enables LLMs to process infinitely long inputs with a bounded memory footprint and computational cost. This is achieved by maintaining a fixed size, compressive memory and performing segment-level computations. Second, Infini-attention introduces minimal changes to the standard transformer architecture, making it easy to adapt existing models for long context processing. Finally, Infini-attention supports continual pre-training and fine-tuning, allowing models to learn from increasingly longer sequences over time.
Can you provide some examples of how Infini-attention has been evaluated in the paper?
The paper evaluates Infini-attention on several benchmarks, including long context language modeling, passkey retrieval, and book summarization. For language modeling, the authors train Infini-transformer models from scratch and compare their performance to baselines like transformer-LLM and memorizing transformers. They demonstrate that Infini-transformer achieves lower perplexity scores while using significantly less memory.
What about the passkey retrieval task?
The passkey retrieval task involves hiding a random number within a long text and asking the model to retrieve it. The authors show that a 1B LLM with Infini-attention can successfully solve this task with input sequences up to 1 million tokens, even when fine-tuned on much shorter sequences. This highlights the model's ability to generalize to longer contexts than those seen during training.
That's impressive. What about the book summarization task?
For book summarization, the authors continuously pre-train an 8B LLM with Infini-attention and then fine-tune it on the book sum dataset. They achieve state-of-the-art results on this task, demonstrating the effectiveness of Infini-attention for handling extremely long texts and generating coherent summaries.
It seems like Infini-attention is a promising approach for extending the capabilities of LLMs to handle long-range dependencies. How does it compare to other methods for addressing this challenge?
Infini-attention stands out from other approaches in its simplicity and efficiency. While methods like compressive transformers and memorizing transformers also utilize memory components, they often have limitations in terms of memory footprint, context window size, or computational complexity. Infini-attention offers a more practical and scalable solution by leveraging a fixed-size compressive memory and a recurrent update mechanism.
Are there any limitations or challenges associated with Infini-attention?
One potential challenge is the need for careful tuning of the gating mechanism to balance the contributions of the local attention and the compressive memory. Additionally, the effectiveness of Infini-attention may depend on the specific task and the length of the input sequences. Further research is needed to explore the optimal configurations and applications of this approach.
What are some potential future directions for research in this area?
Future research could focus on exploring different memory architectures and update mechanisms for Infini-attention. Additionally, investigating the impact of Infini-attention on other tasks, such as question answering and machine translation, would be valuable. Further exploration of the gating mechanism and its role in balancing long-range and short-range dependencies is also warranted.
So in essence, Infini-attention provides a practical and efficient way to extend the capabilities of LLMs to handle infinitely long inputs. It offers a promising solution for addressing the limitations of traditional transformers and opens up new possibilities for processing and understanding extremely long texts.
Indeed, Infini-attention represents a significant step forward in the development of LLMs capable of handling long-range dependencies and processing vast amounts of information. It has the potential to revolutionize how we interact with and utilize LLMs for various tasks, from language modeling to information retrieval and beyond.
Thank you for sharing your insights on this fascinating paper. It's clear that Infini-attention is a valuable contribution to the field of natural language processing, and we can expect to see its impact in future research and applications.